Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fali Fikri bin Muhammad Fawzi with the matrix number 2211635, and we are Group D. And today we'll be presenting about our group project, which is called Smart Healthcare Disease Diagnosis System. So this is our team members, which comprises of four people, who are Hafiz Jais, me myself, Fadi Fikri, Afi Idit, and last but not least is Shafris. So, a little bit of background of our project. So, in the global healthcare industry, there's a lot of challenges where there's increasing demand for quick and accurate diagnostic systems in the healthcare industry. Not only that, manual diagnosis processes often lead to delays or inaccuracies, especially in under-resourced areas. So the role of technology in our project is it's basically a symptom-based diagnostic tools are gaining more prominence for providing preliminary disease predictions, and these tools integrate data sets with symptom descriptions, disease precautions, and also severity analysis to enhance decision making. So the purpose of our project is to basically create a diagnostic tool that uses user-reported symptoms to predict potential diseases. So our project also offers descriptions of diseases and also provides actionable precautions to mitigate the risks. So our objectives for this group project is basically to develop a tool to assist in identifying potential diseases based on symptoms that the users reported. Not only that, we want to utilize data from multiple sources to improve the accuracy of predictions. Not only that, our objective is to be able to provide health information such as disease descriptions and precautions for better awareness. And last but not least is to simplify the diagnostic process with an easy to use interactive interface.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afi Adib bin Hussein Azli Adib, matrix number 221847. So today I'll be explaining to you about our methodology. So first of all, we use the rule-based matching algorithm. So this algorithm forms the core of our program and it works like this. Okay, so first of all, the user select symptoms through a checkbox based on the interface in the program. And then for each disease in the dataset, we check how many of the selected symptoms match the symptoms associated with that disease. And when the user has selected all the symptoms, we will calculate the confidence score with the formula number of the confidence equals to number of matched symptoms divided by the total symptoms for the disease. And then this score will help rank the disease by their likelihood based on the selected symptoms. So the disease with the highest confidence score is identified and will most likely be the disease of the patient lah. And then the program then provides the details like the disease description and the precaution. And then for the severity weights, so each symptom is assigned with a weight that represents its criticality. So for instance, severe chest might have a weight of 10 while cough has a weight of 1. Why? Because the cough symptom is too common. It's a too common disease. Like you cannot detect the specific disease just by a cough symptom because cough is too common. That's why the weight is 1. Okay. So the more specific the symptoms, like I mentioned, the severe chest pain, so it will have a higher weight. So it will help us to know the likelihood of the disease. Okay. All right. So that's all from me. Thank you very much. Assalamualaikum. Okay. So now I'm going to explain about our data sets. So the dataset used for this project consists of a symptom disease mapping sourced from a publicly available healthcare dataset literature. So we use Kaggle, and these datasets were chosen because they cover a lot of disease and symptoms. So it will enable the system to handle many cases. So there are four datasets we downloaded. First one is the system description. and then system precaution, system severity, and system disease. So for system description, it will map the disease to their description. For example, malaria, an infection disease caused by protozoan parasites. And system precaution contains diseases and their associated precaution. For like example, malaria, you can consult to the nearest hospital and avoid oily food, avoid non-vegetarian food, and keep mosquitoes out. And then the system severity, the assign weights to symptom based on their severity, like I mentioned in the previous presentation. The weight, the severity of the symptoms. For like example, just now I mentioned cough, the severity weight is 1, and the severe chest pain is 10. And lastly, the symptom disease maps the symptoms to the corresponding disease. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Shafris Rizwan. My metric number is 2217105. Okay, for today, I will explain to you the user interface of our system, which is Smart Healthcare Diagnosis System. As shown in the slide, we have implemented two different UI frameworks, which is Gradio and Tkinter. For the Gradio interface, which is on the left side, we can see that it is modern, sleek, and also it is a web-based system which making it easy to deploy and use in a browser. So users can select symptom from a large set of options displayed dynamically. So once the system symptom are selected, the diagnose button calculate the most likely disease, confidence level, description, and also precaution. Okay, now for the Tkinter interface, which is on the right side. So this is a desktop-based application which provide a simple, compact layout. So similar to Gradio, user can select symptom from checkbox, click diagnose to predict the disease, and view the result below, including confidence level and precautionary measures. Okay, so now for both interface, they prioritize user friendliness and also accessibility, ensuring user can interact with the system seamlessly to obtain preliminary healthcare insight. Okay, now in conclusion, this project successfully developed a smart healthcare diagnosis system that predict disease based on user input symptom. So for the key achievement, the integration of random forest and support vector machine as VM models ensured high accuracy and robustness in disease prediction. Furthermore, the confidence scoring mechanism made the prediction interpretable, which giving users a clear understanding of the likelihood of each diagnosis. So for the group contribution, the first one is Falih. He is responsible for data collection and pre-processing. For the second member, Brother Afiq, he is responsible for model selection and implementation. For the third member, which is me, user interface design and deployment. And for the last member, Hafiz, he is responsible for documentation and testing. And for the whole code, we do it together as a group. Okay, now for the future development, we aim to explore the use of Hugging Face advanced model to enhance the system. So by incorporating cutting-edge machine learning techniques, we can further improve the accuracy and precision of symptom-based disease prediction because we know that this system need to be accurate for the user to trust the result. Okay, now this project demonstrates the potential of AI-driven healthcare tools in providing valuable preliminary medical insight. By improving accessibility and accuracy, systems like this can play a significant role in early disease detection and also better healthcare outcome. So thank you. Assalamualaikum warahmatullahi wabarakatuh.
Now moving on to the code implementation. Here we use VS Code as our main platform to run our code. And what I would like to highlight here is that we import Tkinter module. Why we use Tkinter? Because we want to run the GUI interface, graphic user interface in our code. So here we can see that there are multiple datasets. There are total 4 datasets that we downloaded from the Kaggle, and system, for example here we have symptom description, symptom precaution, symptom severity, and symptom disease. The 4 different datasets will have 4 different informations, and here we will extract the datasets, and this is the main part of this code function, diagnosis function, where basically the system will generally predict the most likely disease that user click on the particular symptom. Alright, here is the main one of the important part, one of the important line in our code. Let's say if the disease is matched, but if the disease is matched, so in our GUI the system will display what is the most likely disease and all that particular description of the disease and also the precautions and so on. But if the disease is not matched, the description is not available, and also same goes to the precaution. The precaution will also not will be displayed. So in our code also, in our implementation, we will display what is the most likely disease and also the confidence level, as my friend mentioned previously. So I will proceed with our GUI, with our code right now. So this is our disease diagnosis system. This is how our GUI look like, and there are many datasets here that we loaded from that we downloaded from the Kaggle, and we have stiff neck, swelling joints, loss of smell, and so on. So also in our code also we provide an error handling. Let's say if I click on the diagnose without click on any checkbox, without ticking on any checkboxes of the symptoms, so let's say what happened when I click the diagnose. So this is one of the error handling part that we provide in our code, whereby the error handling message is please select at least one symptom. Alright, so I will proceed. Let's say if I click on any random symptoms, let's say I click on mild fever and also back pain. So you might think that both of these symptoms is not correlate each other, right? But what will happen if I click on the diagnose? So you can see this is the message will become no matching disease found, please consult a doctor for further evaluation. So so generally when that particular symptom is not related or not mild related, so this system will cannot predict any likely disease. So I will proceed with how, if let's say I tick on the itching and skin rash, let's say. So maybe I think itching and skin rash might have some similar disease, right? Some similar symptoms. So what will happen if I click on the diagnose button? So this is what the output that we want. Here we have the most likely disease, fungal infection, the confidence level that we calculated using the formula as my friend previously explained. So 0.25. We have also the description of that disease, fungal infection. This is the explanation, and of course the system not only predict what the disease is, but also the system will provide the precautions to that particular disease. So the patient must bath twice, use Dettol, keep infected area dry, use clean clothes, and so on. So this is how our disease diagnosis system works. So I think that's all. Thank you.